Hey, what's up, everybody? Welcome to Health Hazards in Construction. And today we're going to go over just that. There's a lot of different things that we run into on construction sites, and this training will touch on some of the main ones. So, health hazards in construction is actually typically taught in an OSHA 10 or an OSHA 30 class. It is, if I recall, yes, it is a required component of at least OSHA 30 construction. I can't remember with 10 off the top of my head. But I am an OSHA authorized instructor. I've taught it a million times, but sometimes they run together. But this is always a good class, I think, because there's a lot of things that you may be familiar with, whether that's asbestos or silica or noise or what have you, but maybe don't know as much as you might want to know. So this training should help you with that and give you some ideas on what to look for and how to keep yourself safe as you go about your day. So I'm going to get my face out of the way here, get it on down. So again, health hazards in construction, and this will be in two parts. So what are we talking about when we consider health hazards? So common health hazards are chemical, right? Physical, biological, and ergonomic. So ergonomic, you may or may not have heard, we actually have a training on avoiding sprains and strains with low risk, and it is essentially an ergonomic training. We'll touch on that a bit more. So chemical hazards, many of us are familiar with. So we've got an individual here spraying essentially paint. I'm sure it's some type of rust inhibitor. We've got various physical hazards, which are what we think of when we traditionally think safety. Being struck by things, being caught in things, so on and so forth. Biological, so that could be things like mold. Technically, you could probably say silica and asbestos as well. And then ergonomic, which would be another word for that would be human factors. The way that we work, the way that the tools and the materials that we use interact with our body. All of these things can combine to cause different types of hazards to us as we go about our workday. So common ways we encounter chemical hazards, if we start there, using various solids. There are some chemicals that come in solid form. Using liquids, of course, that's how we think of it mostly, I would say. Also gases and vapors and aerosol. So when we're spraying chemicals, well, that makes sense. We can come into contact with hazardous substances. Lawn workers or landscape workers are some folks that come to mind with that, using something that we all use on a regular basis, but using it every day. So one way to determine how bad a chemical might be is the frequency and duration. So someone that is spraying fertilizer or spraying pesticides all day, most days of the week, we're going to want to be aware of that and keep them safer than somebody like me that's going to spray it a couple of times a year on my yard. Other ways workers encounter chemical hazards, asbestos, potentially. So we want to know what to look for there. Now, this isn't an asbestos only class, obviously. If you are regularly encountering asbestos, there's a certain type of asbestos training that you should take. Or if you're in an organization that might need to mitigate that asbestos, there's a certain type of training you should take. This is not that. This is asbestos awareness. So I just want to make that clear. You could be exposed to lead or silica. All of these are various ways that you could encounter typical chemical hazards at the workplace. So I always start this training with an explanation of what the different particles are, because we use these all the time and they're actually different. These being dust, mist, fume, vapor, and aerosol. So a dust is a particle of solid material, and is generally created by a mechanical process. So it says 1 micron to 1 millimeter. I think most of us know what a millimeter is, what size a millimeter looks like. A micron, we don't, but 1 micron is very, very, very small, if not microscopic. But that a dust particle is a solid piece of material. So the easiest way to think about that is a mechanical process. And what material do we use often that could create dust? Wood. So if you have a mechanical process, whether you're sanding or cutting wood, the wood can create dust. Next down the list would be mist. So a mist is a large particle, usually produced by something that's bubbling or splashing or boiling of a liquid. So you have movement of the liquid, and then it creates a mist, but it's a very large particle. Think of the mist that you might drive through on a foggy day, or if you're walking outside of your house and it's misting. Those are pretty large particles as far as particles go. The next one would be a fume. This is where we start getting into particles that, and it's not even a particle really, I guess it is, but we get into a substance that people use incorrectly. So fume is actually a solid particle produced by condensation from a liquid or a reaction between gases. So they're very small. Fumes are very small. You often get fumes when you are interacting with metals. So whenever you're welding, those are not welding vapors or welding aerosols. Those are welding fumes. And they are actually solid particles, but they're just very, very small. It seems like it's a gas or a vapor or something like that, but it's not. A vapor is the gaseous state of a substance. So, you could have, take water. Water has different states. So it could be frozen, it could be water, or it could be water vapor. And the vapor is just the gaseous state of the water. Then you can have an aerosol, a general term for the dispersion of solid or liquid particles of microscopic size. So aerosol is just very small particles. It could be a liquid, it could be a solid, it could be anything. So just wanted to share this with you. Next time you use that word or you see somebody use that word, it might make you think. I think it's good information to have. So a dust is a mechanical process. A mist is a large particle, relatively speaking, that's created from some type of movement of a liquid. A fume is produced by condensation of a liquid or a reaction between gases, or from a process like welding with metals. And vapor is just any substance that is in its gaseous state. So those are very simple explanations, but just keep it in mind as you go about and think through it next time you run across one of these particles. So why do we talk about particles when we're talking about health hazards in construction? It's because depending on the particle size determines at what part of our body the particle will go to. So you have something called inhalable dust or inhalable particles and respirable particles. So inhalable is what you see here, the fraction of airborne material that enters the nose and the mouth during breathing and can lie and can be deposited anywhere in the respiratory tract. They are usually up to about 100 microns. But generally with inhalable particles, they get caught in our upper respiratory tract. So in our nose and our mouth and maybe our throat. And because they're larger, right, they can be up to 100 microns. As opposed to respirable, that is dust that or particles, I keep saying dust, but it's particles that penetrate through our nose, through our mouth, and because they're small, they can get through our throat and then down into our airway, into our lungs, into our bronchioles and our alveoli. And these are the locations where the gas exchange takes place. So these are the locations where when I take a breath in and exhale, I'm having an exchange of gas. And if I get a very small particle, like some of these asbestos particles and some of these silica particles, if that gets down and I respire that, get it all the way down in my lungs, I can have a problem. So that's why particle size is very, very important. This is a great graphic, I think, that shows you what we're talking about. So if you look here, we've got we got our liquids and our solids. So remember how I said a fume is actually a solid? It generally comes from metal. A dust is a solid, right? Think of wood dust. A mist is a liquid, and a spray is a liquid. So down here are our particle sizes. So 0.01 microns all the way up to 1,000 microns right there. So if we look at a vehicle exhaust, it's pretty small, right? And that is one of the reasons that vehicle exhaust is so dangerous to us, and it kills many, many thousands, if not millions of people around the world. Even though the cause of death isn't directly attributed to the vehicle exhaust, we're learning more and more that this is causing a lot of problems for folks. Here's a welding fume. Very small particles, right? And the definition of the fume indicated that that was the case. A fume is a small particle. Atmospheric dust, viruses, asbestos fibers. So this is the diameter. So this is looking at the asbestos fiber from the long way. I'll use a pen. So the diameter of asbestos fiber, looking at it this way, is somewhere between a little bit bigger than 0.01 to about half a micron. So that's why you have problems with asbestos, because it can get all the way down inside of your lungs. So anything, these respirable particles right here, zoom in a bit, anything here about up to about 5 microns, these are what we get deep into our lungs. Viruses, asbestos, as I said, some coal dust, cement dust to a certain extent, fly ash, so on and so forth. So keep that in mind. Here's pollen, by the way. So we have problems with pollen, but pollen stays up here. And those of you who are allergic to things, you could probably agree with that. But it gets caught in our nose and in our airway. So those are common particle sizes, and those apply with what we're exposed to on a construction site. So there are 4 main routes of entry. Inhalation is the most common. Ingestion, so that's swallowing via eating or drinking. Absorption, so that's getting through our skin, right? And then injection, that would be puncture through the skin. So depending on what the chemical is, it's very important. This is why you need to look at the safety data sheet. The SDS is going to tell you a lot of the information that you need to know with regard to how to keep yourself safe and what the route of entry is. Again, most of it is, most chemicals are on some level an inhalation hazard, but you can certainly get ingestion. That would be next most common, and absorption is certainly up there as well, and then injection. Now, typically in workplace health and safety situations, the concern we're talking about with an injection is often a needle stick, but it could be anything else that's causing a puncture through the skin. So what are some of the health effects that we're concerned about? And depending on what the chemical is that we're exposed to can determine whether or not we have an acute effect or a chronic effect. So an acute effect is immediate, happens very fast. The exposure could be, again, fast, short term, and in high concentration. So an example would be here at hydrogen sulfide in a confined space. So hydrogen sulfide is sewer gas. So whenever someone does a confined space operation, one of the chemicals that we're looking for with a 4-gas meter would be H2S, or hydrogen sulfide. And the effects from hydrogen sulfide can happen very fast. They can be acute, up to and including you take a breath and then you go unconscious. So that's an example of an acute effect. An example of a chronic effect would be something that is delayed and takes time, gradually over years. So asbestosis would be an example of that, potentially cancer, depending on what it is. Silicosis, so on and so forth. Those are chronic effects, take time. Both are bad, and both are things generally that are preventable and we want to watch out for. So, speaking of asbestosis, what is it? It is a mineral fiber, occurs naturally in nature, right? So we have asbestos occurring right now. The individual fibers are not visible to the naked eye. So remember, that fiber is about 1 micron in size, probably smaller than that. and the fibers float in the air when they're disturbed. So those of you who have taken asbestos classes before, the word for that starts with an F. Anybody, if you know what it is, it's friable, Friable. So it's not like friable, like chicken or whatever. It's friable. So asbestos does not pose a threat per se until we disturb it, and until we get those asbestos fibers airborne, and at that point we have the possibility to inhale them and then respire them. And then, as I mentioned, they get caught down in our lungs. They don't dissolve in the body, and then we have problems. So where do we use asbestos? It used to be used all over the place, on pipes and ducts, and spray on insulation, on steel structures and steel members, plaster materials, ceiling tile, right? If you've been in construction for any period of time, you've seen it on ceiling tile and floor tile, right? What about those black and white floor tiles? Those often have asbestos on them. Gaskets and friction materials like brakes. They actually still use them for brakes in some instances. Most uses did stop in the 1970s. Spray on insulation, floor tile, ceiling tile. It was used in heating systems through the 1980s, and it is still legal to use them with gaskets and other similar friction type materials. So asbestos needs to be inhaled or eaten technically, but inhaled really to cause the concerns that we're talking about. Exposure often determined by whether asbestos is friable. So often people will have worked with asbestos and are concerned that they've been exposed, but often experts will ask or try to determine, was that asbestos made airborne such that you could inhale it. So friable asbestos can be crumbled by hand pressure when dry. And as mentioned here, non-friable asbestos is not usually a hazard unless it is disturbed. So what are we concerned about? Well, asbestosis, right? So that's scarring of the lung, and it can be disabling. It is disabling. It usually takes 10 plus years to occur. Ultimately, that can lead to lung cancer and also mesothelioma, which is cancer of the lining on the body, essentially. So that generally takes even longer, 20 plus years. So, I know I might speak for many of you that if you yourself have not had an asbestos-related disease, often our fathers or grandfathers or mothers and grandmothers or an aunt or great uncle, somewhere along the line, we know someone that worked in a shipyard or that was in the military or in construction for a long time and has developed one of these health issues related to working with asbestos. So how can you tell if it is asbestos? You can't really. You can suspect, right? So you can look and say, all right, was this building built before a certain year? It depends on the jurisdiction. It depends on the city and the county where you work. I know a lot of places, they'll say before, say 1986 or something like that. I've seen it all over the place. So and if you don't, you should know what the dates are in the buildings that you commonly operate in. But the only way to know for sure is to have it tested by a laboratory, and they will take microscopic samples and be able to determine based on the shape if it is asbestos. So what are some basic work practices that we can implement to mitigate or avoid exposure altogether? Don't disturb spray-on materials. Remember, a lot of the asbestos in the 70s especially was sprayed on to structural members and to steel and things like that. So if you don't know what it is, don't disturb it. That way it doesn't get friable and you don't run the risk of inhaling it. Same goes for thermal system insulation. Don't cut or drill transite board or pipe. Make sure you report any potential asbestos, especially if it became friable, to someone that is in charge, a supervisor, building owner, or someone like that, and you want to stop work. Do not continue to work until you have determined whether or not it is asbestos. You don't want to just say, it might be. We don't want to do that. The amount that OSHA standard says that you can be exposed to is very, very small over an 8-hour period. So 0.1 fibers per cubic centimeter in an 8-hour day is the amount that OSHA says you can be exposed to. You can't even see that level, to give you an idea. So if you suspect it's asbestos, stop work, and until such time someone can confirm. You're going to establish the asbestos mitigation folks are going to establish regulated areas depending on the work that's going on. They'll use a wet method to remove. Often they will do that, and they'll set up a perimeter with signage and basically you don't want to go past that signage. So. But that's asbestos for this class. I do want to reiterate, it's not an asbestos class. This is awareness. Basically what you're looking for are those locations that potentially, based on the age of the building and whether or not it's been renovated, may have asbestos. Be aware of it. If you suspect, stop work and go find someone that can determine whether or not it is asbestos so that you can be safe. Remember, that amount that you can be exposed to is so small that you can't even see it. So that's a very small amount, and we want to help you avoid becoming ill and potentially developing asbestosis or cancer or mesothelioma down the line. So we're going to move on to molds here. So often in my OSHA 30 class, when we have more time and I can be a little more engaging, I spend a lot of time not a lot of time, but more time than normal on mold. And the reason being is I spent a lot of time in a previous career handling indoor air quality issues. And I'm here to tell you that most of the time, the mold you see is harmless, unless you are particularly susceptible to mold. And some people are, and that's fine. And it's not harmless in that instance. But for most of us, it's not going to cause you a problem. And most of the time, the black mold you see is only just that. It is just black mold. It is not the type of black mold that you need to be concerned with. So when I say it's just black mold, it means that's just the color. So what we are concerned with when we talk about potentially dangerous mold is Stachybotrys and Aspergillus. So these two types of mold right here. These are the ones that traditionally, I forget, but maybe back in the 80s or so, when we started hearing about toxic mold, this is what they were referring to. However, most of the time, it's not something you need to be overly concerned about. The color of the mold is not necessarily how you determine toxicity. It doesn't necessarily have to be black. What happens is these molds produce what's called a mycotoxin. And it can be produced by other molds as well. But in a very small subset of people, it's possible that the mold can kind of set up shop and cause like this systemic inflammation in that person's body. But and it can happen. So I'm not saying it can't, but most of the time it's not something that the vast majority of people need to be concerned about. There is also something called sick building syndrome. And without getting into it too much, ventilation in buildings, especially assembly type or office buildings, what have you, is very, very complicated and complex subject, or at least it can be. And it's very important that ventilation gets done correctly in those types of buildings, because you can get something that's called sick building syndrome. And it's essentially a series or a variety of very vague symptoms, but usually people don't feel well: runny nose, coughing, watery eyes, fatigue, various other things with an unknown cause. And often it is related to poor ventilation and potentially mold. So I mentioned this just a bit ago, but molds produce allergens, those mycotoxins. Inhaling or touching the mold spores may cause allergic reactions such as hay fever type symptoms. The reactions can be immediate, they can be acute, or they can be delayed. It just depends. So it's difficult to get. I wrote this. Impossible is a big word, But it's very difficult to get rid of all mold. Mold spores will not grow if there's not enough moisture present, so that is one way we can certainly mitigate mold. The key is to control that moisture. When mold is present, we want to clean up the existing mold that's there, of course, and then stop the moisture source. I know that if mold gets into drywall, it is a challenge. It's often easier just to take the drywall out than to try to replace it, but it just depends on how quickly, how long has that wall been wet, how much moisture is set up shop, and how dry can you get it. But oftentimes I've found it's a losing battle, and it's just easier to take out the sheets of plywood than it is to try to clean up the mold, because it always seems to come back unless you can really control that moisture source. Or else you end up with something like that, which is pretty disgusting, if you ask me. Some of these are just flood damaged homes. That one on the right just particularly skeeves me out. It's just gross. But those are, it's because we have a lot of mold. How do we clean up mold? You need to use some type of biocide. Bleach is a biocide. You want to avoid inhaling those spores in the event that you are particularly allergic to mold. Wear gloves to limit skin contact, protect your eyes. And then depending on how that goes, if you have a continuous mold problem, there's professionals that can come out and help you. They'll test it, see what it is that you have going on, and see if they can identify the source and the cause of the mold. And that's kind of where you get into that sick building syndrome that I talked about. If you have a problem over and over again, at the end of the day, it's a result of having too much moisture, but you may need to bring in a professional to help you determine what the source of that moisture is. And as I mentioned, biocides, bleach is the best way to go. You can look up different percentages to use. Sometimes it's 1 to 10, 1 part bleach to 10 parts water, but or there's chemicals that are meant to kill bleach that aren't, or to kill mold that aren't bleach. Just depends, but that you want something like that is a biocide. Know that dead mold can still cause allergic reactions in some people. It's not enough to kill mold, as I mentioned. You have to remove it. So keep that in mind. Now, how does that apply in construction? If you're doing demolition, if you're doing demolition and or you are installing new drywall or a new wall in a place that has had mold, you're going to be back doing that again if you don't control the source of that moisture. Also keep in mind, just in case, you don't want to inhale it. It's not likely to cause you a serious problem, but it is possible that it could. It's very unlikely, but make sure that you cover your eyes, nose, face, and wear gloves until such time you can get rid of that mold. So that's the best way to think about it with construction. As far as ventilation goes, it is generally our friend. We want to have a combination of local exhaust when we're trying to clean it up. So that means a fan or something like that that's placed right directly on the mold. And then general exhaust, that's going to be for the entire building to make sure that it's keeping moisture levels in the building to an acceptable location. If you're acceptable to mold, wear an N95 respirator or similar. Keep it off your clothing. And, as with anything, use good hygiene practices. Wash your hands. Don't take PPE into clean areas such as your car or your home. And then otherwise, you should be fine. So that is the end of part 1. As you see here in part 2, we're going to start off with silica. But as a reminder, we talked about asbestos. It is a naturally occurring substance, if you recall, and generally doesn't cause us any problems unless it becomes airborne, right? Unless it becomes friable, we inhale it, and then that's very dangerous. The amount that we're allowed to be exposed to is quite small. If you suspect it's asbestos, stop what you're doing, contact a supervisor or similar, and do not do work in that location until such time you've determined that it is or is not asbestos. And again, with mold, most of the time it's not going to hurt you, despite the fact that it's kind of gross. The only way to control it is to get rid of it completely and control the moisture source. But just in case you or someone you work with are susceptible, cover your eyes, nose. You can wear a respirator, N95. And now that does get into something else. I don't want to get too sidetracked, but if you're wearing an N95, you want to make sure that you get into whether or not you need to be fit tested or not. So you want to make sure your employer, what the policy is for your employer if you're going to wear an N95. It could be just voluntary use, and that's fine, but you'll want to double check with your employer, or if you are the employer, make sure you enforce any policies you have with respirators. But an N95 will solve, it will provide some protection, personal protection, cover your eyes, and wear gloves, or better yet, like a Tyvek suit or something like that. So that's it. That's the end of part 1, and I will see you in the next section, starting with silica. Thanks.